For generations, the story of human origins was taught as a neat, linear narrative. The prevailing theory held that early hominins evolved in the cradle of Africa, slowly developed the cognitive capacity to craft tools, and eventually, in a singular, monumental wave, spilled out across the Eurasian continent. But the Earth, as archaeologists know well, rarely keeps a tidy record. Every so often, a discovery emerges from the dirt that shatters the established timeline and forces us to rewrite the history of our species. Welcome to G Fun Facts Online, where we dive deep into the fascinating truths of our world. Today, we are exploring a quiet spot resting in the Jordan Rift Valley, just 3 kilometers south of the Sea of Galilee. It is an archaeological site known as Ubeidiya, and it has long been a crown jewel of prehistoric research. For decades, it was celebrated as one of the oldest known sites of early human occupation outside of Africa. But a groundbreaking 2026 study has thrust Ubeidiya into a spectacular new light. By pushing the site's age back to a staggering 1.9 million years, scientists have not merely altered a date on a timeline, they have fundamentally changed our understanding of the great hominin exodus. This is the story of Ubeidiya, a lush prehistoric oasis, an astonishing convergence of evolutionary technology, and the ancient humans who boldly marched into the unknown nearly 2 million years ago. To understand the sheer magnitude of the Ubeidiya discovery, we first need to picture the landscape of the ancient Levant, as it was 1.9 million years ago. Today, the Jordan Valley is known for its arid, sun-baked stretches, but during the early Pleistocene, it was nothing short of a paradise. The valley was dominated by a chain of freshwater lakes, flanked by dense forests and sweeping grasslands. It was an environment pulsating with life, existing at a unique, biogeographical crossroads where African and Asian ecosystems collided. If you were to stand on the shores of the ancient Ubeidiya Lake back then, you would witness a surreal menagerie of wildlife. Immense elephants and hippopotamuses wallowed in the shallows. Wild cattle and deer grazed the savannas, while apex predators like saber-toothed cats stalked through the dense brush. Within this teeming ecosystem, the bones of extinct bovids with massively flared horns lay scattered among the remains of animals that have long since vanished from the earth. For early humans, this corridor was not just a hospitable habitat, it was a highway. As changing climates in Africa periodically squeezed populations and depleted resources, the lush, water-rich Levantine corridor offered a natural route of expansion out of the continent. The hominins who arrived at Ubeidiya found a land abundant in fresh water, edible vegetation, and large game, an absolutely perfect staging ground for the conquest of Eurasia. The modern story of Ubeidiya began in 1959, purely by accident. A tractor working the land in the Jordan Valley scraped against the earth, revealing fossilized bone fragments and ancient stones. This serendipitous moment sparked decades of rigorous archaeological investigation. Beginning in 1960 and spanning through the 1970s, pioneering archaeologists and geologists peeled back the layers of the site. What they found was mesmerizing. Buried within roughly 60 distinct geological layers of soil were the fragmented bones of early hominins alongside more than 10,000 ancient stone tools. Because the region sits directly on the tectonically volatile Dead Sea Transform Fault, the ancient lakebed sediments had been spectacularly folded and tilted to a 70-degree angle over the millennia. This geological upheaval made excavation incredibly complex, but it also preserved a deep, stacked record of human occupation. For a long time, dating Ubeidiya was the central puzzle. Without the volcanic ash layers that make dating East African sites relatively straightforward, scientists had to rely on relative chronology, which is a method of estimating age by comparing the animal fossils and tool types found at Ubeidiya to other sites with known dates. Using this biochronological method, researchers originally estimated Ubeidiya to be between 1.2 and 1.6 million years old. This date was significant. It painted Ubeidiya as a crucial settlement, but it still positioned the site as a later chapter in the out-of-Africa migration, coming long after the earliest accepted Eurasian occupation at Dmanisi, Georgia, which dates to around 1.85 million years ago. Ubeidiya, it seemed, represented a secondary wave of human migration. But the Earth had a different story to tell. In February 2026, a team of researchers published a landmark paper in Quaternary Science Reviews. Dissatisfied with the uncertainties of relative dating, they returned to Ubeidiya. They reopened an old trench to expose a critical geological layer known as Unit I-26, determined to subject the site to the absolute latest in modern geochronology. To definitively nail down the age of the site, the team utilized three distinct, independent dating techniques, essentially acting as three separate clocks ticking away in the dirt. The first clock was cosmogenic isotope burial dating. When rocks sit on the surface of the Earth, they are constantly bombarded by high-energy cosmic rays from space. This bombardment creates rare isotopes within the quartz crystals of the rock. However, once that rock is buried deep underground, say by a migrating river or an expanding lake, the cosmic printing press shuts off, and those isotopes begin to decay at a predictable, measurable rate. By measuring the ratio of these isotopes in the sediment of Unit I-26, the team gained a direct stopwatch for when the layer was buried. The second clock was paleomagnetism. Earth's magnetic field is not static. Over geological time, the north and south magnetic poles have flipped back and forth numerous times. As sediments slowly settle at the bottom of a lake, magnetic minerals within them align with the Earth's magnetic field at that specific time. The researchers discovered that the sediments at Ubeidiya possessed a reversed magnetic polarity, effectively matching the site to a specific interval known as the Matuyama Chron. This established that the layer was deposited during a magnetic reversal period older than 1.1 million years, pointing heavily to the reversal window between 1.7 and 1.9 million years ago. For their third and final clock, the team turned to uranium-lead dating on snail shells. They looked at Melanopsis, a species of freshwater snail whose fossilized shells were abundant in the ancient lakebed. Originally composed of the mineral aragonite, these shells trap trace amounts of uranium as they fossilize. Over vast stretches of time, that uranium slowly decays into lead. By applying advanced imaging and uranium-lead dating techniques to the shells, the scientists were able to determine a hard minimum age for the artifact-bearing layers. When the results of all three methods were tallied, they converged on a spectacular, undeniable conclusion. The stone tools and fossils in Ubeidiya were deposited at least 1.9 million years ago. To understand why this date of 1.9 million years sent shockwaves through the anthropological community, we have to look closely at the stones these ancient people left behind. At the slightly younger or contemporary site of Dmanisi in Georgia, dated to roughly 1.85 million years ago, researchers found a massive trove of hominin fossils alongside what are known as Oldowan tools. The Oldowan tradition is the oldest and simplest known stone tool technology. It involves striking a core stone with another to chip off sharp flakes, producing rudimentary choppers used for smashing bones to extract marrow or cutting meat. Ubeidiya, however, presents an entirely different technological universe. The artifacts found here, over 10,000 of them, belong predominantly to the Acheulean tradition. Acheulean tools are characterized by large, carefully crafted, teardrop-shaped hand axes and bifacial cleavers. Unlike Oldowan flakes, which are somewhat haphazard, creating an Acheulean hand axe requires a hominin to hold a mental template of the desired tool in their mind before they even strike the first blow. It requires planning, immense spatial awareness, and a sophisticated understanding of stone mechanics. These axes were the multi-tools of the Paleolithic era, used for butchering heavy game, digging for roots, and working wood. Before the 2026 redating, the narrative was neat. Early hominins with primitive Oldowan tools left Africa first, settling in places like Dmanisi. Hundreds of thousands of years later, a smarter, more advanced species wielding Acheulean hand axes evolved in Africa and launched a second migration, arriving at Ubeidiya. The 1.9 million year date completely demolishes this sequence. It reveals that both Ubeidiya and Dmanisi were occupied at roughly the exact same time. The new evidence indicates that both tool traditions left Africa and arrived in Eurasia simultaneously. This is a monumental revelation. It means that the out-of-Africa migration was not a single, monolithic event, but rather a dynamic, simultaneous pulse. At least two entirely distinct groups of hominins, with different anatomies, distinct cognitive capabilities, and different technological cultures, were migrating out of Africa concurrently. carving out different ecological niches in the pristine wilderness of the ancient Levant and the Caucasus. So, who were the people of Ubeidiya? While the site is overwhelmingly rich in stone tools and animal bones, hominin remains at the site are tantalizingly scarce. The fossil record here is fragmentary, primarily consisting of isolated teeth and bone shards. However, in 2022, an extraordinary discovery added flesh to the ghosts of the Jordan Valley. Researchers announced the identification of a perfectly preserved 1.5-million-year-old human lower lumbar vertebra. The bone belonged to a juvenile, likely a male between the ages of 6 and 12. What shocked researchers was the sheer size of the vertebra. Based on its dimensions, this child would have already stood about 70 inches tall, meaning he was massive compared to the diminutive, small-brained hominins discovered at Dmanisi. This physical discrepancy perfectly aligned with the technological differences. The small-bodied hominins of Dmanisi carried simple Oldowan tools, while the robust giants of Ubeidiya, likely early Homo erectus or Homo ergaster, carried the advanced Acheulean hand axes. The presence of the 1.5-million-year-old giant youth, layered chronologically above the 1.9-million-year-old foundational layers, paints a picture of Ubeidiya as a deeply enduring settlement. This wasn't just a brief campsite where migrating hunters rested for a season. Early humans continually lived, hunted, crafted, and died by the shores of this ancient lake for hundreds of thousands of years. Imagine the daily existence of the Ubeidiya hominins. Waking up to the misty mornings of the Jordan Valley 1.9 million years ago. Their survival depended on profound cooperation and acute observation of the natural world. There is no firm evidence that the inhabitants of Ubeidiya had mastered the control of fire. Without the protection of flames at night, they would have lived in constant tension with the apex predators of the region. Saber-toothed cats and ancient hyenas roamed the same game trails, and early humans would have had to secure safe sleeping locations, perhaps in trees or heavily fortified brush shelters. Their diet was fiercely won. The Acheulean hand axes suggest a deep reliance on large herbivore meat. They may have actively hunted smaller or injured animals, but they were almost certainly master scavengers, using their heavy bifacial stone cleavers to drive off other predators from fresh kills, rapidly butchering the meat and cracking open massive bovid and hippo bones to consume the calorie-dense marrow. This rich, protein-heavy diet was the high-octane fuel required to power their growing metabolically expensive brains. The implications of the Ubeidiya redating ripple far beyond the borders of modern-day Israel. It forces the scientific community to adopt a much more chaotic, complex, and fascinating view of our ancestors. The migration out of Africa 1.9 million years ago can no longer be viewed as an evolutionary single-file line. Instead, it was a broad, multi-lineage expansion. The evolutionary tree of humanity during the early Pleistocene was more like a tangled bush, with various species of early Homo overlapping in time and space. As environmental pressures in Africa fluctuated, these diverse groups spilled into the Levantine corridor, carrying entirely different toolkits and physical traits. The new dating of Ubeidiya solidifies the Levant not just as a stepping stone, but as a primary theater of early human development. It is entirely possible that here, in the shadow of the Sea of Galilee, distinct species of early humans encountered one another, observed different survival strategies, and unknowingly laid the foundation for the global expansion of the Homo genus. Today, the physical landscape of Ubeidiya bears little resemblance to the watery paradise of 1.9 million years ago. Tectonic shifts have buckled the earth, draining the ancient lakes and burying the shorelines under immense pressure. Modern visitors to the region are met with a quiet, agricultural landscape where date palms sway in the warm Middle Eastern breeze. Yet, beneath the soil lies the ultimate testament to human resilience and ingenuity. The discovery that early hominins reached this valley 1.9 million years ago, armed with heavy stone axes and an indomitable will to survive, bridges an unimaginable abyss of time. The story of the Ubeidiya migration is a vivid reminder that the human spirit of exploration, the drive to cross the next horizon, to adapt to new environments, and to carve a life out of the unknown, is not a modern phenomenon. It is an instinct forged nearly 2 million years ago in the muddy shores of an ancient Levantine lake. As archaeologists continue to sift through the tilted sediments of the Jordan Rift Valley, one thing is certain: The ancestors we left behind in the Earth still have much to teach us about who we are today. Thank you for joining us on G Fun Facts Online. Keep exploring, keep questioning, and we will see you in the next deep dive into our planet's incredible history.